Hello, my name is Jörg Köhler. I'm heading the business unit Industrial within Bruker BioSpin. We are a global organization providing analytical solutions to a variety of applications. This includes complete value chain coverage, starting from product innovation processes in R&D environments till manufacturing. And here it starts at the front-end side of the process with raw material incoming goods control and goes all the way down to the back-end side of final product quality control. Today I'm delighted to be joined by Vic Singh from Dragonfly Energy. Hi Vic, it's great to be here. Would you like to introduce yourself?
Absolutely. Well, thank you, Jörg and Bruker, for hosting Dragonfly and the team at this impressive facility over the last few days. Dragonfly Energy is a comprehensive lithium-ion battery company. We're headquartered in Reno, Nevada, inside the United States. And the main customer markets we serve are off-grid storage in RV, marine, residential, and continuing to move into new markets. I myself am the director of R&D at Dragonfly Energy, and what R&D is largely focused on is innovating the chemistries and the manufacturing processes associated with the lithium-ion battery cells we implement into our products.
This sounds very interesting. And back in May 2022, we announced our partnership between Dragonfly and Bruker. And it came with the purchase, of course, from Dragonfly of a variety of Bruker solutions, from XRF or XRD, FTIR, but also NMR spectroscopy. This would help Dragonfly, I assume, pioneering R&D processes. So can you tell us more about this endeavor?
Absolutely, yes. So about a year and a half ago, Dragonfly Energy set out to invest in our own infrastructure. And the goal of that infrastructure was to have an in-house understanding, comprehensive, of lithium-ion batteries. Everything from fundamental materials and chemistries associated with those materials to cycling test cells, prototyping test cells, implementing them in packs, and getting the feedback from customers in the field. A big portion of that infrastructure investment was, as you mentioned, a lot of Bruker equipment, XRDs, NMR, XRF, FTIR, Raman, and everything you can possibly think of. And really the goal behind that is we want to be able to paint a complete picture of lithium-ion technology and how it works, both from the fundamental atomistic molecular level, so we can ensure we're designing very sustainable and electroactive materials, all the way up to a fully assembled pack to ensure we're not releasing a product to market that isn't safe and highest quality.
So why is battery research so important right now, and what are the challenges also with maybe what affects society with this? What's the cutting edge of battery today?
Absolutely. No, I think we're in a very exciting time for lithium-ion batteries right now and energy storage in general. There's a lot of innovation taking place, and it's being driven by both public and private investment in this sector. Currently, I think the biggest challenge for lithium-ion batteries is everything is happening so quickly. We want to ensure we create sustainable and secure supply chains as we grow this industry in the near term. Near term, our immediate focus is electrifying markets that have already been identified as technically feasible. So electric vehicles come to mind, residential storage, and an example of what Dragonfly is doing is replacing more toxic energy storage solutions such as lead-acid batteries with more sustainable, cleaner solutions such as our LFP graphite lithium-ion battery packs. So there's quite a bit of opportunity in the space. All of those opportunities come with their own unique set of challenges, but ultimately, the main challenge every energy storage firm is going to face is the levelized cost of that product, storing energy over the course of its entire lifetime. And really, to bring the cost of lithium-ion batteries down, we either need new materials and chemistries, or we need more innovative manufacturing processes. And both of those areas are areas that Dragonfly and a lot of the industry are very active in. I think it's important to note that these endeavors are extremely valuable for battery customers like ourselves, because at the end of the day, Dragonfly is a battery company. We're not an NMR system manufacturer. We're not an XRD system manufacturer. So strong partnerships with firms like Bruker allow us to ensure we're leveraging the infrastructure we invested in to its maximum capability, while also having an open dialogue with firms like Bruker to give you insights into what we're struggling with, what questions we're trying to answer, and ultimately how the systems can better serve those purposes. I think that really helps us set new standards in our respective industries. And ultimately, if we can continue to bring the cost of these lithium-ion battery cells down, more markets will open up, more markets will have components replaced with sustainable, clean energy storage technology. And I think batteries are just one tool in a rather large toolkit we have to combat climate change.
So thank you so much. This is extremely interesting. And Bruker values a lot this partnership because it gives us the opportunity to understand the field of battery better, to understand the electrochemistry behind it, and how we can tailor our solutions platform-wise, hardware-wise, but also software-wise to support you best for going forward. And this is true for floor-standing instruments in R&D environments, but also for derivatives of this technology on benchtop. For example, the Fourier 80 benchtop NMR system equipped with lithium channel in manufacturing environments. So would you see fit or advantages in this, and also quick testing on your desired material in manufacturing environments?
No, absolutely. I think there's a lot of opportunity to apply NMR analysis throughout the cycle of research and development as it relates to lithium-ion batteries. If you look at, from the get-go, we're starting to design new materials. We're trying to understand how those materials react both mechanically and electrochemically inside the battery cell system once operating. These fundamental studies, NMR can be very helpful for on a floor standing level, because we know what we're putting into the system in terms of reactants. We have quite a few destructive techniques such as XRD, SEM EDS, and those sorts of things to study what happened after the battery was cycled. But operando, in situ measurements, and more importantly, studying those reactions in real time, both the soluble and insoluble products, that's very valuable information, and I think that's something that NMR is very useful for. When you start to narrow your chemistries, ultimately, then you have to start thinking about manufacturing. And when you scale up manufacturing, you're not necessarily looking for fundamental reaction mechanisms, but you're looking for tracers of, is this co-block polymer long enough and cross-linked the proper way? Is this lithium-containing compound at the right concentration and right distribution in this matrix? And as we transition over from fundamental materials development towards implementing new materials in prototype and pilot lines, benchtop systems equipped with lithium NMR could be a great way to fast-track those sorts of developments.
Yeah, that's so exciting. So what would be Dragonfly's long-term aspiration, and what would be your dream picture for the future for battery technology?
I think long-term Dragonfly is hoping to expand into new markets. Our core business model has been replacing toxic lead-acid batteries in a variety of applications with a more sustainable, energy-dense, lightweight alternative, which is our lithium-ion battery packs. I think we're going to continue to do that, start expanding into new markets such as residential storage. We have a new product line coming out this spring geared towards that sort of market, and even further into material handling and those sorts of applications. So, growing lithium-ion batteries application in existing markets is always going to be a great way to grow core business. Longer term, what Dragonfly is really working on is bringing a safer, non-flammable solid-state battery to market. And the reason we've pursued that technology for stationary storage in particular is because we believe if you have a non-flammable, cheap battery product, residential storage markets are going to be revolutionized, because you're no longer worried about placing a flammable product on every single home inside a neighborhood. If the cell is non-flammable, it can be much more structural, and it's much more flexibility in terms of where you put it. So long term, we want to build a safer product that allows residential storage to become more accessible. And we want to ensure the materials and the processes we implement when we bring that product to market are cost effective, because ultimately, if we think about addressing climate change, we can't solve this problem in just the United States or just in Germany and developed countries. These products need to be sustainable and cheap enough so they can be implemented on a much wider scale. And I think if we're able to do that, bring a non-flammable, cheap grid storage technology to market, then bringing more renewables onto the grid, such as wind and solar, becomes a lot more realistic, and combating climate change on the power generation level starts to become a lot more tangible.
So can you tell us a bit, where would you see near-term use cases within your R&D environment for the technology of NMR?
Yeah, so NMR is really interesting because at the heart of it, it's very fundamental analytical chemistry. And a battery, when it's cycling, most importantly, so when it's under its standard operating conditions, current is flowing through electrodes, ions are diffusing from one electrode to another. It's a very complex system. You've got, as I mentioned, liquid state ion diffusion occurring, you've got half-cell electrochemical reactions occurring, you've got mechanical factors at play, and then on top of that you have the standard operating conditions of pressure, temperature, and how quickly you're cycling the battery. All of these affect the chemical reactions that occur at the interfaces in the cell itself. And NMR we view as a very powerful tool because right now we understand what we're putting into the system when we assemble the battery. We also have a very clear understanding of the operating conditions those reactants are experiencing. Again, temperature, pressure, cycling rate. What we do not have as detailed of an understanding is what's happening to those reactants in an intermediate phase. Once they form the layers we suspect they will form. And those layers are largely precipitate products. What about the soluble products that go back into solution as a result of those reactions? So we firmly believe that understanding those reactions on a very fundamental level is something NMR can help us with. And once you understand those reactions, you can start to optimize the chemistries and the cycling rates to induce the formation of layers that you desire and ultimately create a cell that cycles for a long period of time.
Well, thank you so much, Vic. It was really a pleasure having you with us today. I look forward to many, many more times visiting you, continuing our partnership. And to all of you, thank you so much for joining us today. And if you have any questions on these topics, feel free to reach out to either Bruker or Dragonfly Energy. Thank you.